Welcome again to the Southwest Climate Podcast. Mike Crimmins, how you
Hey,
doing?
Zack. Good. Happy New Year. Can we still say that? It's
No, we can't.
mid-February. We can't. I know. It's too late, isn't it?
Yeah, I think there's like a rule. It's like you're given like 4 days or something like that.
Oh, I thought it was like June 1st, because then it's like the first half of the year. So grace
Well,
period.
it is there's truth in there, and that is we haven't done a podcast since before the holidays. We did a big
That's
one.
why. Yeah.
Um, and so we have quite a bit to talk about. We've got, what do we have? We've got snowpack conditions. We've got some atmospheric rivers. We got, the strong super El Nino waning. We don't have the monsoon, but I just had to mention it. So we got quite a bit of topics to cover. Um,
Absolutely.
I did want to start this off though, and just pick your brain on what you thought. We didn't prep for this, so I'm putting you on the
Oh.
spot here. But what strikes you so far about this winter?
Um, it's a really good question. So it's starting to feel a little bit like last winter, which I thought was kind of interesting. And part of what made me think that was I looked at some data from last winter and this winter for Tucson, and was surprised at how similar they were, which is really weird because last winter was a La Nina and this year was an El Nino. So that's what's striking me as, that's that's weird.
Yeah, for me, so something similar, although I didn't have the analog year in the four, but I think that the slow start to the winter in terms of rainfall and snowpack and just the juxtaposition between still, and we'll get into this, still a relatively dry, like California high country versus a decent interior West high country. And I
Yeah.
find that as just a kind of a weird pattern, in part because some of what's contributed to a decent interior West also hit California, but California was just at like massive deficits before the last couple of weeks. So anyway, I think the rainfall and snowfall patterns have been somewhat odd to me, but I'm curious about your thoughts when we get to that.
Yeah, I'm excited to talk about that because it's we I have a huge like local bias, like wherever I'm standing is kind of where I'm cued in on what's been going on with the climate. But as we started looking at the maps, it's kind of weird out there. It's kind of weird. Some of it I think is what we kind of expected with a super mega El Nino like we've just been through. And then there's some stuff that's like, this stuff is hard, isn't it? And it doesn't always hang together.
All right, so we'll get there. And I apologize to the listeners as I'm going to be coughing a little bit here and there. It's still overcoming a gnarly bout of the flu. So hope nobody has gotten it, or very few people have gotten it.
Yeah.
Because it is,
Your risk is low from listening to the podcast, though. Like,
yeah, there's,
I don't think that that's still a transmission
it's
vector.
not,
So I
I'm
think
not contagious.
I don't think so. I don't think
Yeah.
so.
Okay. So I thought I'd start this off, Mike, by just recapping kind of the climate, largely the rainfall or precipitation over the last few months. Take us up to, the November, December, January period, and go over that. And then we can hit upon the last couple weeks of February. So we're coming at you in mid-February.
Sounds
All
good.
right. Okay. So November. November, broadly speaking, across the West was a dry month. Sort of the epicenters were Southern California of dryness, Northwestern Arizona, but really like the interior West as well, like Nevada, Utah, Colorado, all the way up to the Pacific Northwest. So very few areas. There was some localized areas of above average rainfall, but broadly speaking, November was dry across the West. Fast forward to December. December flipped a little bit in the sense of The western coast from Southern California all the way up to the Pacific Northwest had areas of above average, few or near average, very few areas below average. The epicenter of the dry was focused toward the high country of California, Nevada, Utah, and western Colorado, and also northern Arizona. So the interior west with northern Arizona, the dry area. And also the dryness extended up into Idaho and Montana and Wyoming. So really the western coast and parts of the Pacific Northwest, interior Pacific Northwest were wet and everything else was dry. So that was December. Fast forward again another month, and January was by and large a wetter than average month across most of the West. Certainly the Pacific Northwest, Washington, Oregon, Northern California were all, and Northern Nevada were all above average. Again, the Sierras, Southern California, Central and Western Arizona were the sort of dry areas. So if we sort of average all those together, and I alluded to this in the intro, the November, December, January period basically had a dry signature, let's say below 50% of average for much of Nevada, the high country of the California, and northern and northwestern Arizona. Pacific Northwest was right around average with a few places above average. So that sort of strikes me as an odd pattern. Again, it's sort of dry in the interior West, Sierra Nevadas, northern Arizona, near average along the coast, western coast, and in the Pacific Northwest. Does that strike you as an odd November, December, January pattern, particularly in the context of an El Nino, or not really, Mike? Are you sort of like, these, we're incorporating November and December, which are wonky months, so maybe not such a weird pattern? Where do you stand?
So the one thing that does stand out to me is that the Climate Prediction Center's outlooks, if you remember us kind of puzzling over those in the fall, the area that they had a forecast for above average precipitation is exactly where the dry anomaly is in Central California and through Northwest Arizona and into Utah. And so it's almost, the climate saw the forecast and decided to go around that area. And so it's almost like an inverse pattern here. And it's just like you said, is that Pacific Northwest over this period has had a bit above average. It's dry in the interior, like Nevada, Northwest Arizona, and then the Sierra California. And then it picks back up again as you get into Southern Arizona and it reaches into New Mexico. So kind of good for us in the Southwest. Not as great for the northern parts of Arizona, which have come back online. So,
and they've come back. We'll get to February in a minute.
Yeah,
I think
that's
February
right. Yeah,
changes the view, but like, let's rewind to
not a lot though, right? I mean, it's still, this is kind of weird, right? Is that we've got this sort of dry signal. So canonically, I love that word. Usually, typically, what you'd see with El Nino is, and this is the way the forecasts typically align themselves, is that through the winter season, you'd see an increased chance of above average precipitation. Southern California, Southern Arizona, New Mexico reaches across Texas all the way to Florida. So that's kind of your hot spot. And it's usually drier than average Pacific Northwest and can reach into the interior Rockies. So you see hints of that right now. Certainly the case, showing up on these maps. So I think what's been going on is that during El Nino events is that you have an extension and a retraction of the subtropical jet stream, right? And so that is the
and where is that in like latitudinally or longitudinally?
So the interesting thing is that
sorry, latitudinally. Sorry,
latitudinally, right? So north-south, right? Okay.
Yes.
So what you typically see is during El Nino events is you have an enhancement of the subtropical jet, and it extends across the entire Pacific Ocean all the way over to East Asia, all the way across, and it's usually a little bit further south than normal, right? And so that's kind of the hallmark, is that there's a strong Aleutian low pressure system, and then there's this long elongated jet. And so that elongated jet can reach right into the southern tier states. And so it shovels storms across the southern tier, which they can look like atmospheric rivers that they can kind of pull up the moisture. And so that is sort of our typical wet stripe across the southern part of the country. What will happen, though, and this is quite normal during El Nino and all winters, is that jet will it will retract and it will expand, especially during El Nino years. And if it retracts, what will happen is that the retraction, meaning that it kind of retracts towards Hawaii in the Pacific Ocean, is that there will be a little ridge that will actually form at the retraction, and so the storms will get
along the west coast.
Yep, they'll get flipped up the west coast, and so they'll end up entering over Northern California, the Pacific Northwest.
So in other words, right? that high pressure, that ridge sort of deflects northward the jet.
Right. And so that happened in 2015, 2016 El Nino winter a lot. And that was the dominant pattern, right? And so that was when we did not see much activity across the Southwest. It was actually average to slightly below average precip for the Southwest, and it was really wet across the Pacific Northwest.
And just for context, that 15-16 El Nino was a strong El Nino.
Yeah, it was the strongest in the record, I believe, at that point. I think it was as strong as 82, 83, 97, 98, maybe a little bit stronger by some metrics. So that one was surprising to us, and it didn't quite deliver what we'd expect. So this winter, I think it's been a little bit more reliable in the sense that we've seen extended jet. It kind of came online in December, January, and especially over the last couple of weeks in February. But it has had natural variability in it, right? That it will retract and it'll extend and it'll retract. And when it extends, it tends to steer the storms through Southern California and then the southern parts of the Southwest and favor what we see in the maps here is like Southern Arizona, and it flips up into a better part of New Mexico. So it wouldn't necessarily deliver the precipitation to sort of the Sierra of California or kind of the interior parts of Utah, Nevada, and even Northwest Arizona. So it kind of fits, seeing what we've seen as far as the weather pattern. The stuff that I've read too is that there's been a lot of moving parts, as there is in every winter, of constructive and destructive interference with the Madden-Julian oscillation and also the Arctic oscillation. And so those are all the kind of widgets and levers that will tug on this. But overall, yeah, it looks like an El Nino winter, and it looks a lot more like an El Nino winter than 2015, 2016 did.
Yeah, and when you actually zoom out and don't just look at the West, and when you look at the entire US, because there are other places that also have an ENSO or El Nino in this winter signal, and those usually are again the southern tier, but Texas, particularly Florida and up the some of the Atlantic coast, with somewhat of a dry spell in the mid-Atlantic area. Not dry spell, but below average conditions. And when you look at sort of a November through current, precipitation map, it's pretty wet through much of Texas and the southern tier of the Southeast and Florida, and up along the eastern coast, and with that dry area in the mid-Atlantic. So it's sort of expressing itself sort of typically. And I'll also note that when you zoom out to the globe, because it's not just in the US that El Nino matters and has an expression, but there's also some common patterns present during El Ninos that are also present during this winter. I'll name a few of these, and this comes from the ENSO blog a couple months ago, NOAA's ENSO blog, which is a great resource. But the patterns, the El Nino typical patterns that have held include like the following: decreased precipitation and drought across northern areas of South America and parts of Central America. That's happened since at least June. Flooding, rains and increased precipitation near the Horn of Africa in early part of the winter, October, November. Drier conditions around Indonesia and the Philippines since late summer. Drier conditions over Australia in the late summer. Wetter conditions across southern India and Sri Lanka. Increased precipitation near Uruguay, southern Brazil. Anyway, the point here is that you even noted it. You sort of went a different way than I thought you're going to go, because in my mind,
no.
yeah, in my mind, like the West still hasn't, unless you include February, and we should talk about that. It still hasn't. It doesn't look like a canonical El Nino pattern to me, but I get your point, and you put a little bit more nuance onto it. But even broader than that, it does look like an El Nino when you zoom out and look at the broader U.S. and across the globe. But February, Mike, February sort of, I would say it had a substantial impact on the rainfall and snowpack pattern across the West. I mean, if you just look at the first 2 weeks of February, and the first 2 weeks of February were characterized by these two long duration storms, these atmospheric rivers, more or less, string of low pressure systems that came in through California, largely through Southern California, and actually sort of swept across the interior West. We can talk about those ARs in a minute, but the precipitation pattern is basically from California, everywhere except for Western Washington and Oregon has seen much above average precipitation, 150 up to 400% of average precipitation. That includes a lot of the high country in Arizona, and also we experienced it in the low deserts as well. But the epicenter there was really San Francisco down to San Diego, and it sort of, those low pressure systems sort of moved eastward. So those atmospheric rivers, Mike, anything about them surprise you?
No, I think that they're to be expected. It's interesting. We've talked about this in the past too. Are they a hallmark of El Nino years? Not necessarily, right? And this is the thing. So an atmospheric river is simply, it's a storm event that has a long continuous fetch of moisture that's able to direct up into, a coastal area with focus, right? So it's able to move lots of water into a particular area very quickly.
Let me put some numbers to that, though.
Yeah, please do.
All right, because I think atmospheric rivers are now common in the public discourse, right?
Yes,
like
they're in the parlance for sure.
Like bomb cyclones are becoming, right?
Yes, that's right.
Okay, so what these things are, they're long, narrow bands of like integrated. So you look at a column of water from the surface up, let's say three kilometers into the atmosphere, and there's a rich concentration of water vapor. They are responsible for globally about 90% of the water vapor transfer from the tropics to the extratropics. So they are a main mechanism of moving moisture from the tropical areas northern. They're characterized by being about this concentrated band of water vapor from about 3 kilometers deep in the atmosphere or high in the atmosphere. They're on the order of 800 kilometers wide, and they can stretch thousands of kilometers east to west. So for California, they tend to bring annually about 25 to 50% of the rainfall. So these happen every year.
Yep.
And there's even more fraction of the winter snowpack comes in these events. So anywhere between 25 and 75% of the winter snowpack is delivered during these atmospheric river events. For Arizona, for those atmospheric rivers to reach Arizona, they have to sort of thread the mountains along the coastal California and Baja and northern Baja area, right? But they can reach Arizona, and I looked at one study from Demaria in 2017, and she looked at the Salt River and Verde River basins, looked at 122 atmospheric rivers between 1979 and 2009. And the total winter precipitation from these atmospheric rivers averaged about 25 to 30%. So less so than California, but still a real big contribution every single year, or on average every single year. Maybe one other thing is that there is a relationship between these ARs, atmospheric rivers, and El Nino, and that is El Ninos tend to increase the frequency of landfalling atmospheric rivers, where La Ninas do the opposite.
And is that for the West Coast, or for what location is that for?
For the Western U.S. So
okay, that's interesting. I had that backwards in my head. I thought it was more frequent during La Ninas.
I've got, without a reference.
No, that's good. Science is good that way.
Yeah. Well, let me read it to you. During El Ninos, when the Eastern Pacific is warmer than normal, atmospheric rivers are more likely to impact the Western U.S. Conversely, during La Ninas, when the Eastern Pacific is cooler than normal, atmospheric rivers are less likely to impact the Western U.S. But there's a caveat too during El Ninos. During East Pacific El Nino events, the subtropical jet extends to the south and east with an anomalous cyclonic flow around a deeper Aleutian low. Mike, maybe you're going to have to translate this in a minute. And more moisture is transported towards North America, and the AR frequency, the atmospheric river frequency, is increased over Western North America. So that's during Eastern Pacific El Nino events. So not all El Nino events are the same, right? We have
right. Yeah.
We have warmer water shifted more toward the east. We think of those as East Pacific El Ninos. And when you have warmer water more focused in Central Pacific, those are sort of Central Pacific El Ninos. So in Central Pacific El Nino events, the Aleutian low shifts further southward relative to its position in the Eastern Pacific. And this shift in the Aleutian low increases the frequency and intensity of atmospheric rivers striking the southwestern U.S. So that goes back to the mechanism where if atmospheric rivers are sort of striking the western U.S., sort of, let's say, California, Mexico border, right? Then they can thread the needle and they make it more into Arizona. And that tends to happen during a central, slightly more so, right? We're talking about low numbers here. Slightly more so during central El Nino than. So anyway, I think the bigger picture is that there is an imprint of El Nino on the frequency of atmospheric rivers. And then even within an event, even within an El Nino event, there's some nuance there too, depending on where the focus of the warm water is in the tropical Pacific Ocean.
That's great, Zack, because that actually helped. That kind of highlights the difference between last winter and this winter. So last winter was very high frequency we had quite a few atmospheric rivers, and they were striking. They did strike Southern California, but they were a little bit more central. And that was where you ended up seeing the snowpack just kind of scream off into stratospheric levels. And it was actually quite wet for much of the Southwest too. And we had record snowpack in parts of northern Arizona, which was a La Niña. And just as you were kind of pointing out, those were really long fetches of moisture from the central Pacific, because that La Niña event would have led to drier than average air in the Eastern Pacific. But this year, as you were just illustrating, is an East Pacific El Nino event. I mean, we got all this warm water along the coast of South America. And exactly what you described is in the period of about mid-January to right up until about now, the Aleutian low has deepened. It's sunk a little bit further south. The jet stream has extended across the subtropical jet is a little bit further south and is extending all the way across the Pacific. And it's basically dumping storms out into the California coast. And that's it. That's actually been the mechanism that's delivered this ramp up in precipitation. It was all that record flooding that Southern California saw. It's also been the rally that we've seen in precipitation and snowpack here in the Southwest since mid-January. Is you can pretty much directly link it back to a much more canonical or typical El Nino pattern with an East Pacific pattern like we saw this winter.
So 2 questions related to this. I want to unpack the Aleutian low a little bit and understand. Okay, so do we know why it forms? Like why does it form during an El Nino event? Like what are the mechanisms, or is this just, do we just recognize this as a persistent pattern, and it's harder to sort of trace the causal mechanisms of it?
So the Aleutian low is actually something called a center of action. And so there are centers of action that it's kind of it sounds like a cooler term than it really is. It's basically a semi-permanent feature that you'd see on a climatological map of circulation patterns across the globe. And so there are other centers of action. There's something called the Icelandic low, and then there's the Aleutian low in the northern hemisphere, so the Atlantic and then the Pacific. And then there are semi-permanent high pressure systems like the Bermuda high pressure, the semi-permanent East Pacific high pressure system. So they're features of global circulation that are emerge because of energy imbalances related to the sun angle and rising air at the equator and sinking air at mid latitudes. The enhancement of it has to do with the shifts in the Hadley cell circulation and the Walker cell circulation. So it's kind of the east. This is so hard to describe on a podcast, right? But I guess that we can.
Doing a great job.
I'm using I'm
drawing it in the air.
I'm drawing in the air. And so when you shift the heating anomaly, which is what El Nino is, it's basically having warmer water where it normally isn't, shifts the circulation pattern with the Walker circulation, which then impacts the circulation in the north-south and south. Well, yeah, from the equator to the north and from the equator to the south, which then disrupts the jet stream pattern, which then can lead to an enhancement of the Aleutian low.
So when you say enhancement, do you mean deepening or
a deepening of it? Yes, I'm sorry. Right. It makes its normal self stronger, bigger, and displaced further south. And so
it's both a location and a strength.
That's correct. Effect. Yeah. And it is in concert with this enhancement of the jet stream, and the jet stream emerges wherever there's a sharp gradient in temperature from north to south. At the surface, it translates up in the atmosphere and becomes an actual, you can look at it like a topographic map. And so where there's, air that's warmer, it's going to stick up higher in the atmosphere. And if it's next to colder air, there's a steep drop off. And that steep drop off creates a pressure gradient. And then that pressure gradient, since it's responding to the Coriolis effect, accelerates. And so in the northern hemisphere, it accelerates to the right, and that is the response and the emergence of a jet stream pattern. And so that then there's another concept called the atmospheric bridge, which I loosely, tenuously have my head wrapped around, which is the relationship between the change in the sea surface temperature patterns and that heating anomaly and how it relates to in a bridge through these different mechanisms back to the Aleutian low in the North Pacific.
Right. There's a chain of events that.
Exactly. Yep. A chain of kind of causal physical features that connect from one location. And this is the concept of teleconnection.
Right. So the enhancement, the deepening of the low, the strengthening of the low, then as you said, it increases the pressure gradients, which drive faster jet stream winds aloft.
Yeah. Yeah. Yeah.
Um,
And it's a chicken and egg thing too, right? It's like what causes what? Well, it's all kind of relating back to the primary causal mechanism, which is the shift in the heating anomaly, or just where that warm water is and where it normally isn't along the
right.
equator.
And this all makes sense now. So people, I'm sure, have heard of these Pineapple Express,
Exactly.
which are the variety of atmospheric rivers that, let's say, that the extension of that really strong jet stream is close to, or if not over, like Hawaii, right?
Yeah. Yep.
And so when you have an enhancement of that Aleutian low, you have a shift south of the jet stream. It's going to strengthen and or pass over like the Hawaii area, which is picking up then warmer, moisture air, right? And so the atmospheric rivers that would then come into landfall on the west would be entraining warmer air.
Yep.
So
Yep.
conversely, because atmospheric rivers happen also in La Nina events, when you have not a deepening or a strengthening of the Aleutian low, you have that the relative position of the jet is a little bit further north. And so the air that is coming in from these in the jet, part of these atmospheric rivers are probably on average cooler than the Pineapple Express is. Now, I just want to be clear that you can have Pineapple Expresses during La Nina too. So there's a lot of other things at play. But just if we're thinking about the average position of the position of the subtropical jet, then it would be cooler air in addition to the rainfall during the atmospheric rivers. Correct?
Yeah. So the weird thing about it, this is where it gets kind of super nuanced here, is that one of the hallmark features of a strong El Nino event is that Hawaii, it's dry. And so that's kind of weird in the sense of like, well, why would that be the case? And so what ends up happening is that you get this, and there's some dynamics here that I don't totally understand. I should because I took a class in it one day, but I can't quite remember. That you get this pair of high pressure systems that emerge just north of the equator, north and south in the East Pacific. And one of them tends to center right over Hawaii. And right to the north of it is a sharp gradient. And so what it is like there's a real sharp gradient from north to south that is the basically extension of the subtropical jet. And so that can happen during an El Nino event. And I'm looking at a map here of the pattern of pressure geopotential heights, or basically kind of where the highs and low pressure systems are from mid-January to February. And there's these twin high pressure systems emerging with the El Nino response, and then this real strong subtropical jet reaching from East Asia all the way into the southwestern United States. And so it looks pretty standard. And again, the El Nino, it didn't look like that for 16 weeks on end, right? It had all this kind of transition, and it was fighting with these other things like the Madden-Julian oscillation. It was phasing into, so in the fall, you've got all of the northern hemisphere kind of changing because of the winter season, the sun angle decreasing, and you don't typically see the real kind of this expression until basically you get into sort of January, February, March. So we're like right in prime season. It's right on time. We're seeing this stuff. The real question to me is this going to keep going? Is this going to keep going over the next month? It has in past years. The El Nino is already starting to weaken. And I saw Climate Prediction Center is now suggesting that they're going to stop leaning on El Nino as a forecasting tool even next month. Like they expect the impacts of it to wane pretty quickly. So that'd be really interesting to see if that works or
But there
not.
usually is a lag between the atmospheric response, right? And the sea surface temperature changes. So like, I mean, probably we can think of like El Nino exerting some sort of an influence for the next month and a half.
Yeah, that I don't, I don't know if it's symmetric, right? Is an El Nino force to the circulation pattern, is it easier to erase it once that wanes than it is a La Nina? Because it always seems like when we get into a La Nina winter, there's always this discussion of a lingering impact well into the spring. It's almost like everybody just assumes that impact. But it was interesting to read this morning that they see this weakening really quickly. There's cold water is going to come to the surface and probably shift this into a La Nina pretty quickly later this spring. And they're already sort of saying, I don't know if we're gonna even draw many typical El Nino impacts on the map later this spring. So yeah, I don't know. It's quite interesting.
So on those couple atmospheric rivers, which I don't know if we should talk about the snowpack pattern just yet, but I'm wondering, because I was paying attention to the weather maps, and it was interesting that you'd have this sort of long wave. You said this on Slack, the sort of long wave trough, and then a bunch of low pressures that sort of rode that trough and brought episodic precipitation across California and into Arizona and up into the interior West. Is that a fair characterization, that there was a number of these sort of low pressures that rode down this longer trough?
Yeah, yeah. I mean, I think that there was a period of time with this extension of the jet. It created a kind of I don't want to say stagnant, but a slow moving long wave trough, meaning that there's like a broad dip in the mid levels of the atmosphere to the south across the west. And whenever you have that, you have the opportunity to actually have low pressure systems kind of cascade through the trough. So they'll kind of move. The opposite of that would be like really progressive pattern, meaning these waves are quickly moving through a region and then there's a ridge on the other side. So it would go from rainy or snowy and then it would clear out and warm up and then so on and so forth. And we certainly see that in kind of a normal year, and we'll probably see that later this spring. But yeah, this was an extended period of stormy weather because of where this trough was parked, and you'd start to see these little short waves rotate through it. And everyone that came through picked up a little bit of moisture. Some picked up a lot, were official atmospheric rivers, and they progressively got colder too, because some of the later part of the storms had access to colder air up north and actually produced more snow later in the period, which was good for the snowpack picking up.
So whenever I look at the maps, the satellite imagery, like what you always see is sort of this, you see a low pressure system, but you see these cloud spirals, counterclockwise. And it's almost like the low is hurling a bunch of subtropical moisture northward, right? And so I'm just like, there's a tendency, I think, to think about like the jet stream as like being the atmospheric rivers, but it's really the low pressure system that is the slingshot for picking up that moisture in that counterclockwise movement and flinging it, like more or less, or entraining it as it moves west to east. Correct?
That's correct. Yep. So the jet stream is, when we're talking about it, this is up at like 30, 40,000 feet in the atmosphere. It's not at the surface. And why that's important is that it is much of the energy to sustain a surface low pressure system, right? And so you had to get a low pressure system, especially long-lived and strengthening ones. Well, first off, to get a low pressure system to strengthen, you need to have a way of actually moving mass out of the low pressure system. And one of the ways is that the energy of the jet stream helps evacuate and sustain the pressure falls at the surface as the low pressure moves forward. And so they work together, right? And the surface low pressure system, in it's surface up to the mid levels of the atmosphere, because when we talk about atmospheric rivers, we're talking about integrated vapor transport, which is going to be the surface up to some lower level of the atmosphere. And so that integrated is integrated up through a level in the atmosphere, and then it's through time. So it gives you like a rate of movement of moisture. So those things all have to align with each other. Sometimes low pressure systems they'll get cut off from the jet stream, and we would call those cut off low pressure systems. And what they'll do over time is they don't typically strengthen, they weaken, right? So they
Because
gradually fill in.
they
That's
lose
right. They
the
lose the
jet.
upper level. Yeah, the upper level support is what would sustain the movement of mass out of a low pressure system to sustain the pressure differential. And a cutoff low gradually, it doesn't immediately, it's not like sucking air out of a bottle and then it pops back in. It's a slow process because of the Coriolis force, and the Coriolis force making parcels of air take very long paths around pressure differentials because it's a time dependent force.
Meteorology is so cool.
It is so cool, and it's got to be insane to listen to it. This is probably maddening to most people.
No, I hope we've already lost them
I know exactly.
All right. All right. So I'm going to give a little bit of the snowpack picture prior to February 1st. And this will give some indication of the impact of, the wet conditions of the last 2 weeks. So across the California region, and this is a number that sort of averages across snow tell sites. So these are monitoring sites at high elevations to record the water content in the snowpack. So across the California region, up through February 1, the region was 63% of average. If we look at the lower Colorado region in Arizona, snowpack conditions were 73%. If we look at the Great Basin region, so western Utah and Nevada, it was 86% of average. And if we go up to the upper Colorado River Basin, up to February 1st, it was about 87% of average, right? And then further north, like the Pacific Northwest, Washington, Idaho, and Oregon, it's 69% of average. Okay, so that what that paints is through February across the West, a pretty dry picture, particularly in California and the Pacific Northwest, with 85% of average in the interior West. Okay, so then fast forward to February 15th. What we have is California boosted from, I've already forgot the numbers, Mike, from 63% to 84%. So a significant increase there. But, it's, again, it was at such a deficit that even those massive 2 storms that dropped, feet of snow in the high country across large areas wasn't enough to push it over average. Okay, but the lower Colorado region in Arizona, now we're up to 131% of average. So that's a substantial increase. Western Utah and Nevada, the Great Basin region, 103%. Upper Colorado River, 100%, right? So, the picture now, as we stand today, is a decent one across the interior West. Even at the sub-basins level, like if you go to the Salt or the Verde, for example, we're at 153% of average snowpack conditions. The upper Gila, 166%. So those are in Arizona. The lower Colorado River, 120%. So the interior West, northern Arizona, pretty good picture in terms of snowpack conditions. California, still a little bit behind. And then as you move north, it gets progressively lower snow water equivalent conditions. So I think you're right, Mike. I mean, I think in terms of what are we going to do for the rest of the winter? We still have, I'd say a month and a half, maybe a month, you know,
Yeah.
less so for Arizona in terms of snowpack conditions. Like the peak time is usually around April 1. So a month and a half there. So there's still plenty of time to make up, deficits from California but also to build more in the in interior West. And again, I would say like that the last 2 weeks really changed the picture and filled me full of a little bit more optimism, at least in terms of snowpack conditions. What's your thoughts?
Yeah, I think that for Arizona and New Mexico, it's pretty good because we usually hit peak snowpack about March 1st. So it's almost like we're coming in right on time. And we're a little bit ahead of schedule with snowpack. And even if we don't get a lot in the next couple of weeks, we might be okay. The Colorado kind of thinking of like Utah and Colorado are they're hitting about average, maybe a little bit above, but they've actually got to keep pace for the next 6 weeks to hit April 1st snowpack. And that's where I'm a little more pessimistic than you are actually, because I'm wondering if we maybe saw what we're going to see and that it's going to be a little bit more of a challenge for that region to keep pace.
So the short-term forecast, though, like looking out, I don't know if you've been paying attention, but it does look like a series of low pressure systems are going to come in again and do something maybe not as intense as what happened in the last couple weeks, but does look like it's going to stream into California and across the interior West.
Yeah, I've been paying attention to so it was interesting, the forecast cycle. Well, when you and I were chatting and we were trying to get you someplace to ski, watching those forecast cycles was a bit maddening because they were so far off at like 5 days, and like the verification has been really, really poor. And so
So
there
I'm
was
glad you
this.
said that because they were
It's so
driving.
true, man. Yeah,
I was like,
they were
what the
not
heck is
great.
going on?
Yeah, well, because it's hard. I mean, it's really hard this time of year. It's so noisy. And, again, what we talked about earlier, it's like the whole hemispheric weather pattern is so churned up right now and is responding to all these different forcings that the forecasts are really having trouble locking on. So there was actually a large event forecast for Arizona and New Mexico for next week. And that was for a period of about 3 days. It looked like we were going to get a storm like Wednesday, Thursday of next week, and it was going to be quite substantial, which is interesting because the last 2 years, I know this because Tucson has this rodeo break, and there have been quite large snow events across Arizona, even with snow down into the desert regions. Well, that's gone. Like that, there was another forecast, and so now the forecast is completely evaporated out through later next week. So now I'm looking at like the 6 to 10 day, 8 to 14, and the week 3-4 forecast by the Climate Prediction Center. So this gets us out to like mid March. It's pretty interesting. The week 3-4 forecast has all of Arizona and New Mexico in a leaning above. But what it is it's a map of an El Nino winter is what the forecast is. And they even say it. They're leaning on El Nino impacts continuing through mid-March. And that certainly could be the case, but there's a lot of other stuff that seems to be kind of at work right now that I'm not
The
sure how it's
8
going
to
to play.
14-day outlook, however, probably does not lean so much on that, or does it?
That's correct. No, and you could see that's interesting. The forecast yesterday for the 8 to 14 had some hints that we were going to be drier than average over that period, and now is switched to being maybe above average. I think it's going to be really noisy. And so what do we normally see during El Nino marches? El Nino marches can be quite wet across the Southwest. And so if this was a La Nina winter and it was March, and we've done this before, right? Like I would hang it up. I think we'd probably be done. The fact that it is an El Nino and it's still going to linger for another month or two, I'd say there's a decent chance that we could pick up some more moisture. So you're making me more optimistic than I
Yeah,
normally
I
would
think I
be.
talked you into
Good. You
it.
just talked me into it. Thanks, Zach. That was good.
Okay, with that. I mean, I think maybe the only other points to hit on is, we talked a lot about this El Nino. It turns out it's either the fifth strongest on record or tied for the fifth, depending on how you break out the numbers. But it logged in, and like you said, Mike, the temperatures are now declining, and so the 3-month running average has fallen below 2 degrees Celsius, but it crested at 2 degrees Celsius above average and over a particular area in the tropical Pacific Ocean, which makes it again the fifth or tied for the fifth strongest on record. So a fairly robust El Nino. And yeah, as you said, you already said this, but I'll just say it again. Looks like the forecasts are calling for a transition later on in the summer into a La Nina event. That's, going from a strong El Nino to a La Nina is not uncommon, but something to keep an eye on looking forward. So yeah, anything else, Mike? What else should we hit?
No, I think, in the next couple of months, we'll revisit the water situation for the Southwest to try to see, how stuff has fared with Lake Mead. So I read today that Lake Mead is now above 1075. Did you see that? It's like, it just kind of rose above one of those critical thresholds that we had talked about.
I did not, but I had a whole suite of web pages to go over. I mean, the streamflow forecasts and the forecast projections are still below average, despite the above average snowpack. And we've talked about this before, but I did read that what ends up being important is what happens after the peak snow. The weather after April 1 is also important as well, and that can really influence it. But yeah, we'll revisit those, or not revisit, but we'll talk about the streamflow forecast projections.
Yeah. I wasn't trying to suggest we're out of the woods. I was, because there's such a long lagging between what the climate does around here and then what the reservoirs do. So there'll be a good, interesting conversation to have about, I want to get your take on like, what does this winter look like in that broader sphere? And then we'll talk about right now, the fire outlook from the National Interagency Fire Center is basically, it's average. So that the outlook is, neither worse or better than average. So we'll just have to kind of keep an eye on that. And then I'm already thinking about the monsoon. I'm already thinking about, what does the transition from a strong El Nino into a La Nina quickly over the spring mean? And I looked, a couple of analog years would be 2016 and 2010. Those summers look pretty good. And
Really?
so I'm already perking up.
Wow. Yeah, I'm like racking my brain of like what happened. It was not a good monsoon season though.
Which one?
The last one. I'm just like I'm trying to
I know.
remember. I'm like
It's terrible.
in the background.
Last summer was not great, Zach. It was very hot and very not great.
Well, good. Well, then those analog years are something to look forward to. Okay.
Yeah, it'll be interesting.
Well, that's great. So yeah, we'll come back in a month's time, and we'll see where things have gone, and it'll either be a bigger snowpack situation, or maybe it'll be dry and
and that's why I'm really curious to see what you think. And this will be a fun conversation for next time is like, okay, where are we at with snowpack and what does this mean? It's going to be interesting.
Let's do it. All right.
Thanks let's do it.
Everybody for tuning in. Appreciate it. Take care.
Zach. It was really fun.
All right. Bye-bye.
too much confusion.